academic world that operates according to the rules that are different from what they were. And who identifies in the audience as a student? So you have 50 years of Sinvestav, which is a great resource to lean on in your work, in your scholarship. And my only request from you is not to take it for granted and not to take this a very astonishing number for the field of mathematics education as some sort of insurance policy that the next 50 years are promised already. It will partially be determined by the work that you will do, by its impact and contribution. Thanks again for the opportunity to be here. This was not part of the 40 minutes. All right. I'm actually very humbled to see all the international guests who have such deep connections with the center. So my interactions with Sinvestav started just last year. So this is in some sense, it's our first date, partially blind. But, so let me say a few words about my scholarship, hoping to open the path for potential interactions, dialogues, and maybe even collaborations in the future. So if I just need to say 3 sentences about my scholarship, I'm fascinated by the phenomenon of mathematics learning, by the processes that go into that. It mesmerized me how people navigate through the learning paradox, how they manage to learn despite everything. I try to be attentive to theory, and I will try to illustrate that to you today. And in the US, sometimes they talk about mathematics education research in terms of the big M or the big E. So the big M is characteristic to people who actually are attentive to mathematics in their educational research, opposed to people who use mathematics as a background to something that can happen in many educational settings. So I am proud to celebrate the big M. It's very great to be among colleagues who I know share this passion. If you are interested to hear voices when you think that your position maybe is, could be reinforced, so I invite you to engage with the Fresh from the Oven book that was published this year, actually. It was published last year. It's part of the series that Professor Kai, Jinfa Kai, is actually one of the editors. And Professor Artig was kind enough to write a concluding chapter for this book. You will see quite interesting reflections of the leaders of the mathematics education community about the role of mathematics in our research and maybe some developments that this theme is going through. All right. When I just started to learn English, as you can hear from my accent, that's not my first language. So when I started to learn English, one of the first sentences that I wrote was, "Mathematics are beautiful." I was very surprised when I got a correction from my English teacher indicating that I made a mistake. And I couldn't understand why exactly it is a mistake, that when you add S at the end of the noun in English, you create a plural. So mathematics is supposed to be plural. This whole talk is about me being right then. I will try to convince you that mathematics is plural, that there is a value in looking at that from this plural different mathematicses, and actually something interesting is happening if we adopt these lenses. Now, this approach is not necessarily shared by everyone. I invite your reactions and disagreements and true scientific debate. It's something that I enjoy a lot. But if we read some reflections, for instance, from mathematicians, they will tell us a different story. For example, mathematics is a coherent tapestry in which all the concepts and skill are logically interwoven to form a single piece. In mathematics education, we acknowledged the power and the critical role of different types of transitions that our students are making just as part of their learning journey. One conceptualization of transition is coming from Michal Yerushalmi, who described critical transition as a learning situation that is found to involve a noticeable change of point of view. A transition would be identified as a necessity for entering into a different type of discourse, or more broadly, as changing lenses. Much has been written and said about transitions in mathematics education, with a big emphasis on very obvious transitions. So we heard in the first day, if I'm not mistaken, from Caroline about the transition from arithmetic to algebra, from reasoning to proof. Anyone does proof in the audience? Okay, I'll get that as yes, thank you. From middle school to high school, anyone is exploring that? Okay. From one language to another, beautiful, thank you. These are mega transitions. These are transitions that are very obvious to all the people who are participating in that. It's not obvious what to do with that, but it's clear that something is happening, right? Like it's like rain, you cannot notice that, right? My interest lies in more nuanced transitions that our students experience. And in many cases, teachers and mathematics educators not necessarily feel that just because we are part of that already. That's one facet of the learning paradox, if you wish. So here is the structure. I will briefly overview a discursive take on the idea of these nuanced transitions. I was inspired by Ricardo's talk yesterday about real and complex numbers, and I thought that it would be appropriate to continue this conversation today, now that we are all refreshed about the historical developments of this topic. I will show you some examples about how students cope with transitions, and I will try to be playful with them in a didactical sense. Okay, so currently my group is working with the learning theory by Professor Anna Svard that came up in 2008 with this book that talks about learning as communicating. And the framework is called comognition, which is like an invented word that combines learning, considers learning as a human activity of cognition that considers that in terms of communication. So this is a neologism of this sort. Professor Svard, the next time you see her on the street, so you will be able to say hello. And the framework builds on the social cultural foundations that we know from John Lev, Vygotsky, and Etienne Wenger, with attention to language from Wittgenstein and other fundamental scholarly works in this area. Who is familiar with the framework, other than Caroline? Okay, cool. Who is not familiar with the framework? Okay, so I need to apologize for both groups. Those who are familiar, you will see how I simplify things. Those who are not familiar, you will see how, even though I try to simplify things, they're still complicated. So my idea is that you will be so interested in that we will continue this conversation over the break, coffee, email, whatever you feel like. One of the features of the framework that it tries to be very explicit about what it is talking about. It likes definitions. So one of the definitions is for the discourse. So discourses are defined as different types of communication set apart by their objects, the kinds of mediators used, and the rules followed by participants, defining different communities of communicating actors. There is a definition for mathematics. This is very rare. So if someone ever tried to define mathematics and was not very comfortable with the exercise, you can have something that you can like, dislike, criticize. It's always easier. Mathematics is defined as a collectively performed patterned activity that involves a repertoire of permissible actions of individual members, a discourse of a special sort. It's a human-made discourse. Now, to help those to grasp maybe one of the fundamental ideas of this framework, I came up with this slide. So if we think about a typical cognitive framework, it works something along the lines of that. There is a reality. There are people who think about this reality. We cannot really enter their thinking process. It's not really accessible to us. So we need to compromise. We need to go with the second best. The second best is what they say, maybe what they gesture, but we have some observable expressions of thinking. So we want thinking, but we cannot get into it, so we look to something that says something about that. So a personal discourse is a window into one's thinking in many frameworks. The cognitive framework does a substantially different epistemological exercise. And it says the following: there is a reality, but we will associate thinking with communication. This is a very particular exercise. We can argue about its validity later. Many people get excited at this point, but what the outcome of that is that thinking becomes accessible for research, in the sense because it's what is graspable, what is tangible in this sense. All right. If we want to be more practical, so when people try to analyze, capture, understand, make sense of students' discourses, they usually look at 4 features. They look at the keywords that are characteristic to a specific mathematical discourse, a function, a derivative, an integral, something that is purely mathematical, and how these keywords are used. They look at what is called visual mediators, symbols, graphs, tables. They look at stories about mathematical objects that students are generating. And they look at how students are performing mathematical routines, like defining, proving, exemplifying, something that we know as purely mathematical. And when we trace changes, did I say that? Yes, what is learning? So here is the definition for learning. A learning is defined as a lasting change in one's mathematical discourse, which occurs through individualization of a discourse that is currently considered canonical. So there is a canonical mathematical discourse out there. Our students individualize it. They create their own version. My version of a mathematical discourse about functions is not exactly the same version as Caroline's, and still we are able to communicate maybe somehow in this sense. And if we want to talk about learning, we need to look at changes in keywords, visual mediators use, narratives that we generate, and routines. Okay. I hope that it gave you some idea about this thing. Now, what I want to share with you today. So this idea that discourses are not really global, and they are really contextual, even though they may sound like we're talking about exactly the same thing. We're talking about mathematics. Why would the discourse on functions in Mexico be different from a discourse on functions in Hong Kong? I'm talking about mathematical discourse. I'm not talking about how it's taught and learned. The expectation is that it's mathematics, right? Have you heard this phrase, 1 + 1 is 2 everywhere? So in some sense, this approach challenges that. It's not the only one that challenges that, but it's one of those. So if I want to go back to this idea of nuance, these small transitions, so we can think about 3 types of them. So if our students are transitioning from community A that was having a discourse on some X, when X is some mathematical object, and they are transitioning to some other community that also has a discourse on X, according to this approach, we can expect some sorts of tensions. And when we think about that, our students are transitioning between mathematical communities all the time. When they open a textbook, if they open a textbook, when they go online to check something with online resources, when they are in a classroom, when they go to some to some mathematical forum to discuss something, right? So it may appear that they're talking about the same thing, but if we zoom into it, we can actually identify some nuanced differences that might be there. There could be another case. If our students are transitioning from community A to community B, but the discourse of this community B is about something else. Okay, so that should be fine, right? Okay. But in many cases, this community B, it does talk about something else, but this discourse is actually a derivative of some version of something that was supposed to happen in the first community for the students. So again, this is a potential source of different types of tensions. What I will focus on today is our students could stay in the same community, so people remain the same. What changes is that we can go from discourse on some mathematical objects to something that seems very similar. And the transition is not really acknowledged, or not acknowledged in a way that emphasizing that some major shifts are happening. Let me show you that with an example of numbers. When I browsed through different numbers and textbooks that talk about different number sets, it's actually quite interesting to look at the diagrams that the textbook authors putting there to represent the relationships between number sets. So for instance, this is one variation of that. This is another variation of that. We can think about how similar, how different they are. This is an interesting one. And we can think about what kind of messages, what kind of ideas these things actually communicate to us. But one of the strong ideas that many textbooks use, and even some educators use, is the idea of yes, we're changing our number sets, yes, we're changing our numerical systems, but we are expanding. Have you heard this? Expansion of number sets, right? And I would argue that this is actually a metaphor. Let's see how it can play out. So for instance, Alejandro González Martin and his team, so they explained the idea of introducing new numbers in the following way. The learning of different sets of numbers can be seen as progressive extension of the initial perception of numbers through the algebraic structure of nested number sets, from the primitive notion of counting to the ideas of comparing, measuring, and solving equations. Progressive extension. So we had something and we just extended, right? Why are we using this metaphor? Why, from all the ways in which we could describe that, why we talk about extension? We can think about different justifications for that. First of all, one of the most basic pedagogical ideas that people like to emphasize and celebrate is that new knowledge is supposed to grow from the existing one, right? So the idea of connections. So this extension metaphor is building on that. When teachers and textbooks are justifying new numbers, right? We want to justify why we are complicating the lives of our students. So we usually show that the existing number sets are inadequate. There is some problem with that, right? Like when we have natural numbers, we cannot deduce a larger number from a small number, or it's a disaster, let's expand number set, right? So the new number sets are compensating, are fixing something. So great, we have a problem, we have a solution, nice story. And again, by using this metaphor, we are actually perpetuating the quote that I showed you at the very beginning, in which mathematics emerges as a beautiful, perfect, coherent set of rules and objects that work so brilliantly and beautiful internally, right? Now, let me go back to the idea of real and complex numbers and show you, first of all, why it is so appealing to think about that as an extension. But I will not call it as an extension, I will call it an overlap. An overlap of what? An overlap of discourses. And discourses are defined according to these 4 features. So I will show you the overlap, or I will remind you of overlap. So first of all, in terms of the keywords, when we talk about real numbers, when we talk about complex numbers, so there are some words that are exactly the same. Number, addition, all these things, right? Okay. Visual mediators. We still use plus and minus and the square root symbol and many other things. We still use some version of a number line or number system when we represent numbers geometrically with points, right? So this thing remains the same. The narratives, the mathematical narratives about the object. So still, if we have a number and we add 0, it remains, right? So many things remain. Routines. The addition is like, we don't need to talk, right? The addition works exactly as we used to. There is nothing to learn in this sense, right? Like, if you try to actually explain that there is something very deep that happens here that's a matter of definition, the students will be very surprised that we are spending the time on that, right? Because it's symbolic manipulation. Okay, so this is clear. Now let's talk about incommensurability. Incommensurability is coming from the fact that when discourses do not align, they are incommensurable. In real numbers, we're used to talk about positivity and negativity of numbers. We are losing this property in complex numbers. Think about how fundamental it is. In most curriculums, complex numbers are studied at the very end of secondary school, if at all. So for at least 12, 13 years, numbers were comparable for our students. And suddenly it's lost. That's a big tragedy. We were able to order numbers. Complex numbers don't have a natural order. By the way, if anyone is working with students, this is a very fun thing to prove that could be eliminating if you're looking for something like that. In real numbers, teachers are investing a lot of energy to convince students that the square root of x squared is not x. It's the absolute value of x. And it comes usually with a lot of effort and a lot of pain for all the parties involved. The same for all these algebraic manipulations. We cannot do that in complex numbers. Why we cannot do that with complex numbers? Because we are incapable of choosing between two roots. In reals, we were able to choose because we would say, yes, there are two, but you choose the positive one. But we lost positivity. Right? De Moivre theorem actually says that it's not working, the rule that we were used to in the past. And there are very nice paradoxes, or sorry, it's not a paradox, it's a sophism, that we can play with to show that something is happening, quite entertaining. And where is Ricardo? Ricardo, I insist that you cannot do that because of what we were talking about today, and I should be defined through squaring, not through square rooting for this reason. So hopefully you saw that there is a fundamental incommensurability between R and C if we look at that through the lens of discourses from the mathematical point of view. The fact is that if you analyze some materials from courses, from textbooks, I dare you to find opportunities for students to become aware of that. Because what is my interpretation? What we emphasize in different ways is the idea, dear students, don't worry, we're just extending, it's just an extension, everything will be okay, don't panic. Because if they will notice what is going on, this is shocking. So this is what I did. I wanted to shock them and to see what will be their reaction to the shock. So a questionnaire was developed with some follow-up interviews. Many students partook in it. The structure was very simple. It was really not about the calculations. It was more, I'll show you in a second, just to say, most of them were engineering students in the second or third year of their studies, and all of them had exposure to calculus, linear algebra, and sometimes even more advanced courses in complex analysis. Some students provided explanations. The idea of the questionnaire was that they were provided with very simple calculational exercises in real and complex numbers, and they needed to choose a single number as an answer, or both numbers, with some explanation, hopefully. So something like that. So in complex numbers, the square root of -9 is that, or that, and here they can choose both of them and explain. Does it make sense? Okay. So what are the results? So from the mathematical point of view from which I'm coming, I expected them to be sensitive to the discourse. So out of 115, only 16 was saying, yes, there are real numbers, they operate in one way. Yes, there are complex numbers, they operate in another way. Sometimes it's the same, sometimes it's different, but it's not a big deal. So they were aware of the transition in some sense. Other students were sensitive to the number under the root. What does it mean? That when the number was positive, right? Like the thing was positive. So they acted in one way. When it was purely complex, so the imaginary part was not zero, they acted in another way. And when it was negative under the square root, so they acted maybe in some other way. So what determined for them was, what are we square rooting from? And we can explain it in different ways. For instance, different symbols, different mathematical objects, right? This is something that we learned throughout the whole curriculum, that if you're talking about some new mathematical object, we need a new mathematical symbol. If the symbol is the same, so the object is the same. And they explained that. So around half were talking about one size fits all is supposed to work according to like their numbers, so they're supposed to work exactly in the same way. Some of them, some square roots give two numbers, right? Like everywhere, no matter what. Some students were actually, they were saying like, root is a multivariate function. It's an international convention to provide this, the positive root, right? So the idea of positivity is something that they associate with both discourses. And some students were actually mad with me. Why do you always mention the field? Root of a positive number remains the same no matter where. Right? Okay. So one of the follow-up interviews that we did was with a very high-achieving student, mathematics major. She was at the end of her degree, and she was familiar from complex numbers from school and at least 2 mathematical courses that she completed successfully. We started with a very simple exercise of this thing. I don't even want to give it a name, not to bias you in some way, in real numbers. So Anna sketched a graph of a function, everything is worked beautifully. Okay. Then I'm asking, okay, so how about this thing in complex numbers? Okay. So according to the Moaber, she does this very complicated thing. K, blah, 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 1 or 2, we got -3, 3, she's finished. I'm kind of, okay, so you got 2 results. Right. I'm kind of, okay, does it bother you that you got a single result earlier? Maybe it doesn't bother her. I know, Anna says. I should have also gotten 2 results then. It was a mistake. By definition, b is the root of a if b squared equals a, so -3 and 3 work. Notice how quickly she discards her previous work, and she immediately creates a different mathematical narrative to justify something that could appear as an incoherence. I'm kind of, wait, but you had a graph. But you had a graph, right? Like you cannot drop the graph so quickly. She kind of, right? The graph? And kind of, so she tells me, all your numbers, my numbers, they're my numbers. All your numbers are squared, so the square root of a squared is the absolute value. She was taught that. Then we get absolute value of 3 is ±3, says a mathematics major after 2 courses in mathematics. I'm kind of, the absolute value of 3 is 3n -3. She said, right. I'm kind of, can you show it on a graph? And this is the graph. My point is not about that Anna was correct or incorrect. That's not the point. My point was to show you the process of what happens when we actually draw students' attention to something that may appear as conflict between mathematical narratives, how they amend their ways on the goal. So what I was trying to show you, that even mature students, when I say mature, I mean mathematically mature, may be not aware that mathematical objects are discourse dependent and that the same words and symbols can point at different objects in different discourses. And they can interpret the situations as incoherence and as a mistake in their mathematics. And the attempts to fix this incoherence may lead to systematic renunciation of perfectly valid ways of thinking. Okay, in this last bit, I want to show you that if we actually take out this idea of mathematical coherence from the pedestal, we can actually treat it as a didactical variable with which we can play that may give rise to new teaching approaches, maybe to new studies. I will be curious to see your reaction. So what will happen if instead of convincing the students that we are just expanding with all the problems and potential issues that I illustrated just now, what we will try to do the opposite. What will happen if we will use another metaphor for the transition, and what if we will emphasize that we are transitioning? What does it mean? That there was discourse 1, we want to transition to discourse 2, the discourses are different. What we're trying to do, we're trying to normalize the differences between discourses. So we are going to talk about the metaphor of transition. Within this metaphor, learners are encouraged to depart from one discourse to arrive at incommensurable discourse, discourse that works differently. Differences within this metaphor are expected norm. Similarities are a pleasant surprise, not an expectation that it will happen all the time. And maybe if we do it that way, we will try to attune learners' mindset to be alert to potential differences that are coming their way. This is just a didactical intellectual exercise in task design, so please don't expect some results. I would be happy to talk with people if they're interested to do that. So what we're going to do, in light of the overlap is there, right? Like we can, it's difficult to do something about that. So let's mask it temporarily for some time in order to emphasize the idea of transition. So let me, for just a couple of minutes, to introduce you to a new mathematical world. In this mathematical world, there are creatures. The name of these creatures is tau, or taus in plural. Okay? So your question could be, okay, how we operate with these taus, what can you do? So let me teach you an operation. The operation is tapiritanga. Who is familiar with the operation of tapiritanga? No one, right? So you need a definition, because you don't have anything to rely on. So let me teach you how to operate, how to do tapiritanga with taus. You take two taus and you create a parallelogram. The vertex that you get in the corner, so that would be the result of tapiritanga. Okay? Now, it's very not natural, it's very not organic, it's not very clear what to do with that. So we can ask questions about this, how this operation works if we have three taus. And what happens if we have this O in the middle? And so we can ask all these questions and we can play with that for a significant time. So what you guessed, of course, in this audience, that what I just did was to use the Maori language in order to mask, to put a wheel on something which is familiar. So instead of telling students that we are transitioning from real numbers to complex numbers, we are not even saying that these are numbers. So at this point, if someone will try to do that, my hope will be that after a few lessons of playing with these taus and tapiritanga, once the teacher says, actually, the word tau in Te Reo Maori is a number, the students need to rebel, or I hope that they will rebel. Because they need to ask, wait a minute, in which sense it's a number? Which could raise a fascinating discussion, what makes a mathematical object a number? Being a number is a mathematical property. By saying that we're transitioning from real numbers to complex numbers, we ensure that this property is in place. In this geometrical way, we can actually create an intellectual need for convincing students that these creatures with which they play geometrically deserve to be treated as numbers. Does it make sense? It's a fundamentally different idea to talk about something that, in my view, we rarely talk about in secondary curriculum and even in more advanced stages. Then we can go back and ask, wait a second, so if we can play with numbers geometrically and algebraically, could we do that before? Why we didn't do that much before, right? Does what we learned now, does it hold for what? But it becomes a question that could be checked rather than something that we just expect and we don't understand why we're talking about it. Now, there are different views on this approach that I was discussing with mathematicians, so not all of them were happy. Within this approach, the relationships between different number sets, it's a matter of a mathematical stance rather than a deductively derivable results. So some will say that the metaphor of extension comes from the mathematical idea that numbers are nested subsets in each other, right? So something like that. The metaphor of transition that I was introducing today is actually talking about numbers as being isomorphic, in the sense that one set has a subset which is isomorphic to the number set. Who is right? Which mathematics is right? So I claim that it's not our problem. It's something that mathematicians should argue about. Our problem is in how to make students prepare to use different views, different approaches, depending on the mathematical circumstances, to be able to handle a wider range of problems. So Rina Tsatskis, John Mason, and I came with this idea of a wedding cake. If you look at the wedding cake from above, you will be in a situation of nested subsets. If you look at that from the side, you will see it as isomorphisms, and you can use different perspectives depending on what you need. If you are curious about games of this sort, you are welcome to explore this book series about numbers, and they have more interesting books as well. What I was trying to say in this talk, I was trying to illustrate and hopefully convince you that mathematics learning requires transitions across discourses and communities, which often requires coping with incoherence. It's part of the game. And if this is the case, the educational agenda could be that it's our professional obligation as educators, is to assist students in their learning of how to accommodate, appreciate, and celebrate differences between different discourses and communities, and to learn to transition between incommensurable discourses and to participate in them meaningfully. Thank you.
Thank you so much for your insightful presentation. We really appreciate your contribution to this conference.
Thank you.
Continuaremos entonces con la reacción de las doctoras Asuman Oktach y Diana Villabona, quienes compartirán sus reflexiones y comentarios.
Hola. Como dicen todos, este tiempo no cuenta. Bueno, hola, buenos días a todos. As per Igor's request, I'm going to be speaking in English, then Diana is going to speak in Spanish, but we are not going to say the same things, although they will be related. We are going to be complementing each other, rather.
El día de hoy, dada la circunstancia del conferencista, vamos a hablar tanto en inglés, Asuman lo va a hacer, y yo complementaré los comentarios de Asuman en español. Entonces, va a ser necesario que todos presten atención a ambos discursos.
So we are going to start, our intention is to start a dialogue with Igor after his presentation of the interesting work that he's doing. And our reflections are going to be in two directions. On the one hand, we are going to think in terms of APOS theory about the phenomenon of passing from one number set to another. And that has at least two reasons. One is because it is natural for us to do so. We work with APOS theory. And the second reason is that we had to make sure that in this 50th anniversary of the department, APOS theory should be present.
Vamos a empezar entonces con algunas dificultades que reconocemos desde la perspectiva de la teoría POE en la problemática que enuncia Igor. Entonces estamos totalmente convencidas de que esta problemática es latente y es persistente y que puede ser abordada desde múltiples perspectivas, por ejemplo, desde un enfoque didáctico, un enfoque cognitivo, y dado que lo cognitivo es nuestro espacio de trabajo, allí nos vamos a centrar.
So the first part of our reflection is from APOS theory. The second part will be more directly related to Igor's presentation. We are thinking in terms of when you are passing in cognitive terms, when you're passing from one context to another, in this case it is the number sets, what is being gained and what is being lost. So there's some new knowledge coming in, but there are also things that you have to leave behind because there are some rules that are coming into the picture.
En estos términos vamos a reflexionar teóricamente, dado que el objeto matemático que trae Igor el día de hoy no ha sido un objeto de estudio para nuestro grupo de investigación, a pensar qué pasa en términos de los constructos de la teoría POE en esas transiciones, ¿no? ¿Qué va a permanecer, qué se pierde, pero en términos de nuestros elementos teóricos?
So, in terms of APOS theory, actions are a very important part of knowledge construction. They are really the building blocks of how new knowledge is constructed. So, and that's because we start the construction of knowledge by applying actions on previously constructed objects. And in the construction of number sets, we are seeing a wealth of actions all over the place.
Dentro de nuestro grupo de investigación hemos estado trabajando sobre la naturaleza de las acciones desde diferentes perspectivas. ¿Qué pasa cuando la naturaleza de un objeto cambia y la acción, por ejemplo, es la misma? ¿Qué implicaciones en la construcción tiene esto, no? Entonces, en este caso en particular, donde suceden transiciones entre conjuntos numéricos, la construcción de los conjuntos numéricos implica que van a haber acciones que eran admisibles inicialmente y que dejan de serlo, acciones que no eran admisibles y pasan a ser admisibles, o acciones que tienen que redefinirse.
So we can think about some examples. For example, if we are passing from the natural numbers to the integers, there were some operations that were forbidden. We couldn't subtract 5 from 2. Or, Michelle has very interesting work on this. We can think about it in terms of solving equations also. There are some equations that we were able to solve and some we are not able to solve. And in integers, this becomes possible. But even more problematic than something becoming possible or something being added to the existing knowledge, it is more problematic to leave things behind. Maybe I was interpreting multiplication as a repeated addition, but suddenly this doesn't make sense in the context of new numbers.
Algo que me gustaría recalcar es la suma y la resta en un contexto de los naturales son dos acciones distintas, pero cuando logramos extendernos al conjunto de los enteros, o más bien en términos de Igor, transicionar a los enteros, estas dos acciones dejan de ser dos acciones distintas y pasan a ser una única.
So we can think about similar kinds of phenomena from passing from integers to rationals, for example, or from passing from rationals to reals. There is always something that is being added and something that we have to leave behind.
En el caso particular, en el paso de los reales a los complejos, creo que Igor reflexionó bastante alrededor y no vamos a detenernos especialmente en estos ejemplos, pero creo que la idea es clara, ¿no? Siempre, cuando hay una transición de un contexto, de un dominio a otro, hay acciones que se pierden, acciones que se ganan y acciones que se redefinen. ¿Qué implicaciones tendría esto en términos de la actividad cognitiva? Desde la perspectiva de Dubinsky y Piaget, ellos estudian la construcción de esquemas cognitivos, que básicamente es la organización de todo nuestro conocimiento. La posibilidad de aplicar nuevas acciones o de redefinirlas o de darse cuenta de que una acción deja de ser admisible está relacionada íntimamente con distintos procesos de asimilación y de acomodación del esquema, en donde pues, el esquema de número tiene que irse adaptando dependiendo del dominio en el que se está tratando.
So the idea of some actions being admissible, some actions being inadmissible, some of them requiring new kind of interpretations, is closely related to the structure of schema, if we think in terms of in cognitive terms. So sometimes we can assimilate new knowledge into our existing schema because our schema is mature enough, it is coherent enough. But sometimes if there is a discrepancy that is really huge, then there has to be first an accommodation in the schema, and afterwards we could assimilate the new knowledge. And this has to do, of course, with the coherence of the schema. I think they changed. But anyway, I'll continue with this. We would like to bring to your attention this quote from Michel's work, especially the last part, where we are seeing that actions are little by little constructing new objects. So when we apply more actions, we are constructing a different aspect of that object. And this is very closely related to a notion, theoretical notion that we have been working with, especially in the context of infinity, which we call facets. So more actions we apply, the object becomes more coherent, more robust, more sophisticated.
Un constructo en el que hemos estado trabajando, Solange, que se encuentra por allá sentada, Asuman y yo, es la idea de facetas. Con esta idea de facetas, que es un aporte nuestro a la teoría, lo que estamos intentando caracterizar es el hecho de que hay objetos que hemos identificado especialmente ahora en el infinito, que no se construyen a través de una única aplicación de una acción, sino que se van construyendo de manera gradual a través de las distintas acciones que podemos ir aplicando sobre el objeto. Esta cita de Michel nos lleva a pensar alrededor de esta idea de las acciones en términos del conjunto de los complejos. Entonces podríamos pensar, es una pregunta que nos hacemos, que tal vez el conjunto de los complejos se va construyendo en facetas que se activan o se posibilitan cada vez que vamos aplicando nuevos tipos de acciones. Algunas de esas acciones como la aparecen ahí en la parte de abajo de la transparencia.
As we said, the construction of schema in the context of passing from one number set to another is very intimately related to the idea or notion of coherence of a schema. Because at the end, we would like the students to be aware of the fact or ask themselves the questions, where am I? What are the rules here? And how can I solve this question? All the decisions that are made and that are brought in the resolution process have to do with the idea of coherence of the schema.
Me gustaría plantear una metáfora para explicar un poco la coherencia del esquema. Supongamos que todo nuestro conocimiento está organizado en una caja de herramientas y que cuando llegamos a algún lugar y nos plantean un problema, el hecho de saber qué herramienta o qué conjugación de herramientas puedo utilizar para resolver ese problema está relacionado con la idea de coherencia.
So there are some other questions that are brought to us by our readings of Igor's work and our reflections from the viewpoint of APA's theory. Now, does the transition metaphor intend to avoid situations where an action becomes inadmissible in the new context, or does it have another kind of didactical intentions? Is the same metaphor, or can it be useful in all transitions? For example, when I'm passing from naturals to integers, from integers to rationals, no matter what the nature of the objects involved, or the sets involved, or the operations involved.
La segunda dimensión de reflexión que nos gustaría traer el día de hoy está relacionada con qué tanto podemos alejarnos del conjunto de números que nos es familiar y sobre el cual hemos construido toda nuestra capacidad operativa relacionada con los números.
So the second direction that in which we reflected has to do with how far we can distance ourselves from the real numbers when passing to the complex numbers. We are going to base ourselves on this quote from Igor's work, where they say, within the transition metaphor, students are not asked to mobilize familiar numbers to engender new ones, but instead encouraged to depart from one numeric set to arrive at another.
Consideramos que matemáticamente tal vez sea posible construir el cuerpo de los complejos sin atender a los reales inicialmente. Pero nos planteamos la pregunta, ¿podría hacerse esto desde una perspectiva cognitiva?
So we are thinking that when we are passing from real numbers to complex numbers, we are really entering a different world with unusual objects or operations or elements, unusual in the sense that all we have learned about numbers so far was rooted in the real numbers.
Toda la experiencia operativa que tienen los individuos cuando se enfrentan a la construcción del conjunto de los complejos está relacionada con el conjunto de los números reales. Quiere decir que todas las operaciones están definidas en términos de la naturaleza de los números reales, todas las propiedades y todo lo demás. Cualquier planteamiento posterior que se presente en relación al número va a estar permeado por esas estructuras y esa organización. Entonces nos planteamos preguntas alrededor de cómo poder alejar, aunque sea discursivamente, a los individuos de ese conocimiento previo.
So we are breaking here again what Igor presented in his talk, the two metaphors, the expansion metaphor where the previous set is being seen as the subset of the new numeric set, and the transition metaphor as he presented as a wedding cake today, where we are leaving what we had learned before, but we are entering into a new realm. So we were thinking about the whole educational system and when students start learning about numbers and at what age they start passing through these number sets. For example, if we are going to do all this transition starting with the natural numbers, are the students mature enough mathematically, cognitively, to think in terms of isomorphisms and all that is required by this transition metaphor, for example, from passing from naturals to integers? or if we're just going to do it from reals to complex numbers, now there's a wealth of information and customs that students bring with them, and how are they going to handle the new set?
Sí, una forma distinta de plantear la pregunta es, ¿tendría la metáfora de las transiciones formas de ser adaptada para, por ejemplo, tomar en cuenta la madurez matemática cognitiva dependiendo de la situación específica de cada uno de los individuos, y además atendiendo el hecho de que cada una de las transiciones tienen naturalezas distintas y cambia en términos distintos, son acciones distintas que se redefinen o que deben ser definidas de cero o que desaparecen?
Now, finally, I would like to say that Igor's work caused us a lot of reflection in terms of our work and in terms of perhaps new future research studies. So we thank Igor for that. Maybe we will be communicating with him in the future. But we have been thinking about possible research questions that can be studied from these considerations.
Especialmente para mí, uno de los aportes que nos llevó a hacer este diálogo fue el hecho de pensar en qué contextos es interesante estudiar la coherencia, algo que nunca hasta ahora habíamos pensado como grupo y creo que tampoco ha sido publicado. Creemos que estas transiciones entre los distintos conjuntos numéricos puede ser un escenario fértil para estudiar la idea de cómo alcanzar un esquema coherente, cómo las distintas reglas del juego el individuo puede usarlas dependiendo del contexto en el cual esté trabajando. Entonces, agradecer nuevamente a Igor porque tanto su plática el día de hoy como sus distintas publicaciones nos han llevado a pensar e incluso a repensar nuestros constructos y la forma en la que podemos usarlos.
So there are many historical, epistemological, cognitive, didactical considerations in this work, and if we can study them separately, togetherly, I think it would be a really nice line of work. Thank you very much.
Muchísimas gracias.
Agradecemos a las doctoras por compartirnos su reflexión, y ahora que dejamos este espacio abierto a la audiencia, ya sea con preguntas o comentarios. Quien desea participar, le pido que levante su mano y le haremos llegar el micrófono.
Gracias, buenos días. De verdad la plática de hoy, bueno, me siento muy agradecida por estar en este espacio después de haber salido ya hace un tiempo. Y para mí fue muy interesante el hecho de cómo se trabaja, cómo trabajó la parte de que no se trata de solamente la expansión, sino transición. Y eso me hizo recordar el planteamiento de obstáculo epistemológico de Piaget precisamente. ¿Qué implicaciones tiene ese obstáculo epistemológico? Pero va más allá. ¿Qué tanto los profesores, que somos los que estamos trabajando, nos damos cuenta de esos obstáculos, pero como una posibilidad de promover el aprendizaje y ayudarle a los pequeños o ayudarles en identificar las herramientas que les permitan esa transición y no solamente expansión? Esto me recuerda a un episodio de trabajo con unos pequeños de tercer año, niños de 7, 8 años, que jugando con fichas con la recta numérica, llegó un momento en que pasamos al término, ya no eran números naturales. Y por ahí preguntó, ¿y estos números qué vamos a hacer si llegamos al 0 y todavía tengo más números? Es un buen obstáculo epistemológico que fue interesante, pero que me cayó de sorpresa porque yo nunca pensé que un niño tan pequeño iba a llegar a esa reflexión. Entonces, esto también implica que el profesor también pasa por este proceso y que también tendría que tener claridad en que no se trata de expansión, sino cómo ayudar. Me encantó una frase que decía ahí, no continuar, sino romper y pasar al siguiente sistema o reconocer que hay más allá de lo que acostumbrados estamos. Yo creo que es una de las dificultades por las cuales los niños es complejo cuando tienen que pasar al pensamiento algebraico. Gracias.
Thank you so much for your reflection and for the story. I really appreciate that. This story and your reflection actually made me think when Arina and John and I were writing this paper, so we needed an example of a transition, and so I'm very happy that we didn't go to natural numbers, even though that I think John wanted to go to natural numbers, because people have reactions to that. One thought in relation to what I heard today was around the question, are the transitions between different number sets, are they really similar? So we can classify the transitions, right? And this is an interesting idea to think about, clearly depending on where we want to go with that and what we're trying to achieve, right? In the sense, my kind of very initial thought on the spot in reaction to the examples that you were giving as well was, there might be a difference between what you called, we knew something, we are transitioning, something needs to change, we need to leave something behind. And I think in the case, for instance, from natural numbers to integers, or from integers to rationals, it's not really leaving behind, it's saying not always. So it's not that the multiplication cannot be thought as a repeated addition, it's just not always. And this is one type of a transition. What I was trying to show today from reals and complex, this is really about abandoning. Like, this is really, we are departing. Because in my view, the differences are overshadowing the similarities. So I fully agree that it was never my intention to talk about isomorphism with the pequeños. That was never my intention in general. But there is something about... No, maybe I'll stop at this point. Yeah. Yeah.
I want to say something because it made me reflect about how much we want to avoid obstacles and how much we want the students to overcome obstacles. I think there should be a balance between them. For example, the cognitive disequilibrium that happens when you see a new knowledge that is not coherent with what you were doing before, I think it's a very good opportunity to advance your knowledge and also advance your reasoning skills. But we don't want the students to be battling all the time either, and if there are obstacles that should be avoided, so I think those are like epistemological, didactical concerns that can be researched. Mm-hmm.
Well, I have a remark and a question also. One is that the first time I read the book of Cognition, it was related to a thesis that Caroline Kieran was conducted with a student, and she asked me to be a member of a jury. But I read recently that Anna is changing, stressing the word or the problem of communication about people and itself, rather than talking about cognition. I think that it's better to talk about the problem of communication as now she's stressing and putting more easily to understand the word cognition. It's a remark that. But the other is a question. And it's a question that is related with your presentation and the use of the word transition and the reaction made after your presentation. If I understand, I'm going to give an example, one example to stress my point of view. In one exam about limits, I asked to calculate a limit of a rational function. The students, some students arrived to write something like infinite multiplied by infinite is going to give infinite, and divided by infinite is going to give 1. Others say 0, etc. But one student wrote, when x goes to infinite, I'm going to take x equal 10, x equal 100, x equal 1000, and it said, I guess the limit is 0. Then I was thinking about the problem. The problem, my students' use of the infinite, and the student that he went to arithmetic to give an answer. And I think that I would like to use the word articulation as Asuman and Diana was stressing instead of the word transition from a cognitive point of view. My question is if you agree about the stress that Asuman and Diana are doing about the importance of articulation rather than transition. About the difference? Yes, articulations, I think that is something that you can use given a situation. For example, you can find a counterexample using arithmetic when it is a question of calculus, for example. But you are going back to arithmetic to bring, and the word transition, I think that is going only on one direction. An articulation, as I understand Asuman and Diana, is about the two directions.
Awesome, thank you so much for that. Okay, now I have a better understanding of what you're talking about, and it's a great opportunity for me to reflect on the choice of words. Okay, first of all, I agree with you that we should be able to think backwards and forwards. And according to my understanding of the word transition, it's absolutely possible, because we chose transition, not immigration. Right? But this is semantics. We can talk about that. What was interesting for me, especially in your example of calculus, something that I did not consider in these terms, is the use of what is even conventionally talked about in the studies of calculus as arithmetics, right? So on the one hand, according to my experience with teaching and learning calculus in different countries, there is a few lessons when a teacher introduces all these complicated epsilon delta definition and these exhaustive exercises that students need to do according to the definition. And then at some point, their life becomes easier, because they are given permission to use the arithmetic of calculus. And this is a very interesting, from didactical point of view, this is a very interesting move in the sense, because on the one hand, it's very clear that everyone is suffering. For many people, it's very difficult to work with these definitions and to show that. On the other hand, we are often, without articulating that explicitly, but we are allowed, in cognitive terms I will say, to bring rules from arithmetic to something that until now we were positioning as substantially different. And in many cases, or some teachers in some classrooms, they prove the rules of arithmetics. I always question, like, if students really appreciate all the energy which is spent there, or they just want to use the results because the results are so natural. But we actually, so in cognitive terms, in terms of a classroom discourse, it is a fascinating thing to think about. The beginning emphasizes the differences and the changes and the new narratives that we want to grow and the new routines in which we justify. But at some point, we compress this complexity by giving the permission to use familiar rules that we are bringing with us, or we know that all of us share. And what I find especially confusing for all the parties involved in this exercise is to getting a clear understanding. I will bring another term to this conversation about the social mathematical norms of calculus. Specifically, what you should prove, let's say according to the definition and in some new ways, and what you can just use. And this is always not easy, neither to understand these rules of this new game, nor to be explicit about it. Why? Because in many cases, teachers are teaching the same course over and over again. So they are actually experts in their own discourses. They can easily lose the sensitivity of newcomers. Thanks for the example.
¿Hola? Sí, ya. Ok, gracias. Bueno, creo que levanté la mano cuando ya casi va a terminar. Bueno, es un comentario en función de lo que es nuestro 50 aniversario, la invitación que se le hizo a Igor y ustedes que jugaron el papel de reactores ante la presentación. Pues en ese sentido, yo tengo una necesidad, pues sí, es una necesidad de apreciar lo que se expone y llevarlo como a una especie de unidad. Es mi ejercicio que yo estoy teniendo en este evento. Entonces, voy a empezar a decir esto. Me pareció muy interesante la perspectiva que nos presenta Igor, donde nos habla de una transición y nos habla de discursos en diferentes comunidades, y quiero entender que está diciendo un estudiante vive en diferentes comunidades o grupos y tiene diferentes discursos y suceden transiciones, y de ahí se trata de explicar qué pasa con la relación de los números y pone en juego los números complejos. Y entonces viene la reacción y se habla de los números y de los números complejos desde la visión Apoe, que me pareció bien interesante, y aquí viene la idea del ejercicio. Es decir, pues evidentemente son dos visiones, y eso lo tenemos que entender en las discusiones. Entonces, se pone en juego esto, bueno, ¿qué querrá decir esquema? ¿Y qué querrá decir transición? ¿Cómo explico la transición y el discurso cognitivamente hablando? O sea, y eso pues puede ser válido, o sea, estamos haciendo investigación, estamos haciendo diálogo con, y ahí puede ser lo interesante. Ahora, yo quisiera como regresar a la discusión de ese discurso, de esa transición, y yo diría de esa visión cognitiva. Cuando se habla de los números, yo veo pues que se habla del tema de los números, pero no veo qué hace que yo piense en los números, ¿verdad? O sea, no veo que y entonces no veo ciertos aspectos que pudieran estar ahí y que puede ser, por ejemplo, yo me preguntaba, porque yo también tengo mi visión, y entonces también me pregunto cosas, y yo digo, ¿qué papel juega en toda esta perspectiva, tanto cognitiva como la transitiva, y yo pondría guión, discurso? ¿Qué papel juega la variación? ¿Qué papel juega la cantidad? Para poder entender entonces cómo se va a transitar con los números. Y cómo es que pudiera tener una situación que me haga pensar, dado que tengo los números reales, por decirlo así, a los complejos. Entonces, ¿qué rol juegan ese tipo de elementos cuando se está hablando? Yo hasta diría, creo que se habló de una forma muy intrínseca a los números. Entonces se habla de un desglose de números. Pero no veo cómo es que a un niño se le pueda motivar el hablar de números y pasar por toda su transición cognitiva, o pasar por una serie de discurso con respecto a otros niños, etcétera, etcétera, ¿no? Entonces, yo no sé si tenga esta respuesta, pero no espero eso, sino solo como una reflexión. Y yo sí creo que es bueno tener este tipo de ejercicios, porque para mí era inevitable pensar tanto en esos procesos cognitivos y en esas transiciones de discurso, pues en lo que yo hago como resignificación. Yo diría, la matemática se resignifica entre los niños, entre los diferentes niveles escolares, en el paso de la vida, etcétera, etcétera. Pero no quiero decir que eso hay que imponer ese tipo de aspectos, sino cómo vamos como jalando todo lo que hay para ir ganando entendimiento y sobre todo a una problemática, ¿no? O sea, es comentario solo.
Bueno, una conexión que hicimos y que fue la que tuvimos en cuenta para la reacción es lo que significa la comunicación, ¿no? Que es como la problemática que el día de hoy está abordando Igor, y que, bueno, debo resaltar luego de leer varios de sus trabajos que él muy amablemente nos compartió, que no es desde la única perspectiva desde la que él ha abordado la problemática. Ha utilizado muchos elementos, varias teorías, incluso ha utilizado los esquemas. En una de sus publicaciones aparece. Entonces, nosotros podemos ver la comunicación como uno de los fines del pensamiento. Pensamos y comunicamos, ¿no? Y una manera que tenemos metodológicamente desde la teoría POE es a través del discurso. Caracterizamos las posibles concepciones que tienen los individuos. Entonces, ¿qué quiere decir eso? Que los discursos que está tomando en cuenta Igor nos pueden dar una idea de la actividad cognitiva subyacente al discurso. Entonces, en esos términos empezamos a pensar en esas transiciones y el discurso que se tiene cuando se transita entre ellas, lo que se solapa y lo que no, qué actividad cognitiva subyacente tiene atrás. Y para eso, pues, vimos necesario pensar en la estructura esquema, la que le da la E a POE, y pensar qué tipo de mecanismos estarían involucrados en esos tránsitos. Y veíamos que tal vez enfrentar con verdades viejas, digámoslo así, o verdades ciertas en conjuntos familiares, conjuntos que se pretenden construir que son nuevos, puede generar desequilibrios. Y en términos de Piaget y también en términos de Apoe, esos desequilibrios se enfrentan a través de los mecanismos de asimilación y de acomodación. Entonces, pensábamos que estas distintas transiciones y las acciones que se posibilitan, se imposibilitan o que deben redefinirse, lo que tienen por detrás es un montón de asimilaciones y acomodaciones del esquema de número, ¿no? Pensando el número como un esquema completo. Asuman, no sé si... ¿Igor? ¿No? Entonces, esa es como la conexión que determinamos y algo que nos permitiría a nosotros reflexionar en conjunto. Sobre todo, como digo, entendiendo que Igor ya se acercó a la idea de esquema en alguna de sus publicaciones. Idea de esquema de Dubinski, no de Piaget. Entonces, creo que en esos términos hemos querido reflexionar. En cuanto a la idea de cantidad, y bueno, otras tantas cuestiones que deben aparecer dentro del esquema y que permiten relacionar el conocimiento para construir lo que nosotros concebimos como número, pues creo que en este momento no tengo manera de responderte porque ni siquiera hemos pensado en una descomposición genética que nos permita de alguna manera modelar en dónde aparece la idea de cantidad y las otras tantas ideas que pueden estar relacionadas como las propiedades de orden y otras tantas cosas que van y vienen, ¿no? Pero creo que esta actividad del día de hoy pues sienta las bases para un trabajo interesante, como digo, que podamos hacer en los términos de nuestra teoría y dentro de nuestro espacio de investigación.
Bueno.
Thank you so much for this comprehensive comment and the question that you made. I'm definitely not going to answer it. But it made me think about three things that I will try to put forward as a potentially food for our coffee break. One is mathematical. So according to the question and the answers and that I hear in the room, that there seems to be a consensus that coherence is important in mathematics. This is something to reflect on, I think, and to kind of delve into the history of why coherence is such a value in mathematics for mathematicians, and there is actually quite a bit of work that is coming from people who are taking a different view of that talk about the problematics of that. The other idea is pedagogical. We know that students bring their old knowledge to the classroom where they are supposed to get new knowledge, whether we want it or not. It could be like a robust finding that we know from different things. So we need to work around it, I think. It's something important to take into account. So it's like a pedagogical need which is in practice. And I think that this is an attempt to think about that. The last one is theoretical. So I really appreciate the connection with the Apos theory, and I'm very happy to hear that you carved the space in these celebrations for the Apos theory, and it's great to connect. But in light of what we know about theories, and we have an expert on that, theories do not connect easily. And not every theory connects easily to another theory. So I think and it also relates to the idea of coherence and not coherence, and do we want mathematics education to be coherent? But I think it's good to create a mental space to the possibility that these things are not coherent, and they will never be. So the conversation could be around what each of them can contribute to the discourse that the other cannot.
the meaning we can give to the word coherence. I think that having different perspectives on the same object doesn't mean that we are not necessarily coherent. Diversity, for me, is compatible with coherence. And mathematics is, by essence, very diverse and more diverse. Which does not mean that we are not looking for some coherence. And I appreciated a lot this efforts made to connect appos and cognition. And I think that they give us different looks at different perspectives on similar phenomena. When we work with numbers, we work with objects that are submitted to operations. And this is something common to them. And I remember from the work on the complex number that, and listening to Igor, I was thinking, what is he saying about the task, the discourse about square roots, for instance, in France? It would not be admissible to say that a real number, positive real number, has only one root. It will be emphasized from the beginning that he has two roots. And that the fact that the field is ordered allows to, by a convention, a pure convention, not a mathematical truth, a pure convention to say that the positive root is written in. And very often when you move to the complex field, you don't use, you pay attention to using, for instance, exponents, 1/2, instead of using always this. And the fact that it is not an ordered field is put, the emphasis is put in the teaching from the beginning. So I agree also with Asuman and when they say what we gain, what we have to live, and the fact that in didactic choices, it is very important. So for me, it's not perhaps just the metaphor that it's capturing, but also the how. Perhaps another theoretical frame can enter the frame for that. And the metaphor of the transition, as you presented it, reminded me the teaching of numbers in the 70s, when we applied this metaphor, was applied directly without any didactic transposition. So the field of integers was presented as something with an isomorphism, with, and the same thing was with couples of integers for the rational numbers. It was not so successful, but the idea of transition was taken too much literally. Yeah. And I am sure that you don't take it literally.
Bueno, por cuestiones de tiempo vamos a terminar aquí los comentarios y preguntas. Sin embargo, los invitamos a seguir reflexionando junto con los doctores, acompañados de un café y galletas. Nuevamente agradecemos al doctor Kontorovich y a las doctoras Oktach y Villabona por su presentación.